Hi guys, Sajad Hussain again with a new video. In this video, I am going to discuss uh, design of a 12-story building according to UBC-97 and Pakistan Building Code. Why I am going to design a building with such an old code UBC-97? That is because in Pakistan we are designing the buildings as per Pakistan Building Code. Especially the loads are defined as per Pakistan Building Code. And Pakistan Building Code is dependent on UBC 97. That's why to educate our new engineers, especially in Pakistan, I'm recording this video so that they can benefit from it. And especially the seismic provision of Pakistan Building Code, which is in line with UBC 97, should be very clearly understood. Actually, why I'm following this Pakistan building code, because now I have moved from Saudi Arabia to Pakistan and now I'm living in Islamabad. I have registered my company over here, and my company's name is MSH Associates. I'm working as a structural design consultant in Islamabad. I got the registration of my company from Pakistan Engineering Council, and also I registered my company with Capital Development Authority CDA, which is the licensing authority for designing buildings, especially in Islamabad. Now let me show you my certificates. This is my certificate from Pakistan Engineering Council, which says that certificate of registration of Pakistan Consulting Engineer. And here is the name of my company, MSH Associates. This is my address, and I'm working here in Islamabad. Also, I have been registered in Capital Development Authority. This is the certificate from Capital Development Authority. I'm registered as a structural engineer, and my enrollment number is given over here. And now I'm entitled to design structures, especially buildings in Islamabad. So, having this information, I would like to convey to you, or I would like to inform you guys that now I'm in Islamabad and I'm working as a structural design engineer here in Islamabad. Let me show you the Pakistan Building Code over here. You can see this is the first page of Pakistan Building Code with seismic provision of 2007. This Pakistan Building Code is totally dependent on UBC 97. Now that's why I am following the structural design requirements of UBC 97. So all the formula, the conditions, everything is the same over here. But there is a difference in Building Code of Pakistan. Basically, Building Code of Pakistan has redefined the various cities in Pakistan with the various seismic intensity or seismic zones. Like, for example, I'm living in Islamabad. As per UBC 97, Islamabad is under seismic zone 4, which is very severe seismic area. And that is very true because the city of Islamabad is at the edge of, I can say, the lower Himalayan limb. This lower Himalayan limb has experienced some earthquakes before, like it was in 2005. There was a severe earthquake in Kashmir, and because of the Kashmir Valley damages were there. There was a multi-story building fell in Islamabad. After that, the people started thinking that this is a serious threat in Pakistan also, and we should develop our own building code. And as a result of that, in 2007, the government of Pakistan approved this building code of Pakistan. Well, although I have some reservation, but this building code is dependent totally on UBC 97. Now the dilemma is, if I'm going to design a concrete structure and I'm following Pakistan Building Code. In Pakistan Building Code, they are not very clear that which ACI standard should I follow. So logically, if I am following UBC 97, I should follow ACI 31899. But when I open ACI 31899 and I took the load combination, but there is a warning that in ACI 31899, the earthquake is defined as working stress load. It is not ultimate load. But in UBC 97, the earthquake is treated as ultimate load. So that means if I am following ACI 31899 load combination to design my structure, then the load combinations are wrong. I cannot follow that. That means I have to follow UBC 97 load combination or Pakistan Building Code load combination and its provisions. So to make this all clear to the engineers, especially the young engineers here in Islamabad and in Pakistan, I'm preparing this video so that it should be helpful for them. I took an example from PCA notes on ACI 31899, and here this example number 31.1, calculation of seismic design force for a 12-story frame shear wall building and its components. Let me show you the building first itself. This building, the building plan is here. The building has 7 bays in horizontal direction, and vertical direction there are 3 bays, and it is a 12-story building. The first story is the first story height is 16 feet. All other stories are 12 feet height. Various sections, like for example, edge column is 22 by 22 inch, interior column are 26 by 26 inch, beams are 20 inch by 24 inch, and there is a slab of 8 inch thick. The walls are 8 inch in web plus 32 by 32 inch boundary elements. So all these informations are there. I took this example as a reference because the seismic zone 4 is the building is designed as per seismic zone 4. Seismic source type is B, soil profile is SB, and importance factor is 1, etc. As I told you that Islamabad and Karachi, both cities, as per UBC, fall under seismic zone 4. Although Pakistan Building Code has lowered the severity over here and they consider is seismic zone 2B, but in my opinion, both the cities, especially Karachi and Islamabad, both should be in seismic zone 4, and we should be very careful in designing the building, especially the multi-story building in these two cities with these conditions that we should consider seismic zone 4 instead of following blindly Pakistan Building Code, which has lowered the severity over these two cities. In my opinion, I should be following UBC recommendation. Because if you are following UBC recommendation and taking these two cities as in seismic zone 4, you are safe because the code requires only 2B. But if you are designing as seismic zone 4, that means you are safe. So in any case, you are not going to lower the severity and your structure will be safe. God forbid, if there is any earthquake, your structure will be safe enough. That's why I took this example and I'm going to design this with a stand. But before designing, I prepared a report in MathCAD. So let me share the MathCAD report for design calculation or the load calculation. So here is the structural design calculation. I took these figures from PCA notes and I'm telling over here that this is 12-story building design according to UBC-97 or PBC-2007. Of course, I'm considering this in seismic zone 4 instead of considering seismic zone 2B. As I mentioned before, even though PBC 2007 says it's seismic zone 2B, but I'm going to follow seismic zone 4. Site condition, the building is assumed to be either in Karachi or in Islamabad with seismic zone 4 and soil type SB. Of course, wind load condition, as per the conditions given over here, what I considered here is the basic wind velocity is 70 miles per hour or 112 or 13 kilometer per hour. Exposure category is C. The CEA stricta table is given. Importance factor is 1 and the pressure is calculated as per UBC 97 with table 16H. Earthquake design data, as I mentioned, seismic zone is 4, so Z will be 0.4 G. Seismic coefficient Ca will be 0.4 Na, where Na is 1. Cv will be 0.4 Nv, where Nv is equals to 1. Soil type is SB. Importance factor I is equal to 1. And of course, the R value and omega values are 8.5 and 2.8, and in north-south direction and east-west direction, both the conditions are the same. So just I compiled all these values over here. Going further down, the material considered F-C is 4000 psi. The density of concrete is considered as 145 instead of 150 pound per cubic feet. Fy is equals to 60,000 psi, which is acceptable both by Pakistan Building Code and UBC 97. Let me go down for load calculation. Of course, dead load I have considered 8-inch thick slab as mentioned. So the dead load comes out to be for the floor is 126.667 pound per square feet and for the roof it is 106.667 pound per square feet. Live load as per the conditions given is for the floor it is 75 pound per square foot and for the roof it is 20 pound per square feet. Wind load I have calculated as per UBC. So the velocity is 70 miles per hour. Importance factor is 1. So I tabulated the height, the levels and the height, its tributary area, the value of CE from the table, the pressure is calculated and the force. So all the forces Wind forces in windward direction and leeward direction is calculated manually over here. Basically, the formula is given over here that the wind pressure is equals to CV into C into CQ into Q into I. Similarly, in this was for north-south direction, and for east-west direction, I calculated the wind force similarly in the same manner. Then I considered the seismic load and I calculated the seismic load. The height of the building is 148 feet. CT is 0.02, X is 0.07 in north-south direction. The fundamental period comes out to be 0.894. And the coefficient for base shear comes out to be Vs is 0.0555, which is within the limits. So this is the value of Vs. And in east-west direction, and in north-south direction, what I did, I manually calculated the story height, story weight, and distributed the load in along the height. So total base shear comes out to be 1481.98 kips. Similarly, in a east-west direction, I did the same thing. I calculated the fundamental period, which is 1.273 second, and based on that, the value of Vs comes out to be 0.044 because actually it's less than that, so we have to consider 0.044. And the similar way, I calculated the story shear at all the levels, and finally the base shear comes out to be 1177.02 kip. Then let me go to the model. What I did here, this is my stat model. You can see the geometry is there, properties. Of course, these shear walls are 18-inch thick. All the columns at periphery are 22-inch by 22-inch. Beams are 20-inch by 24-inch, and the inner columns, they are 26-inch by 26-inch. And the important thing is the loading. What I did, I defined the seismic load in the seismic load generator, and all the parameters are given over here. Self weight is as a given, and the floor weight is also given as per the calculation over there. And then when I go to the load cases, I define all the load cases. That means load case number 1 is in the earthquake in east-west direction. Load case number 2, earthquake in north-south direction. Load case 3 is the dead load. Load case 4 is the live load. The loads are already defined. Load case number 5 is the wind in north-south direction. Load case number 6 is the wind in east-west direction. Load 7 is the reducible roof load, which is over here. And then the important thing is the load combinations, which is calculated and assigned over here. Now, I run this model and let me show you the important factor. When I got the result, that is what I wanted to share with you. You can see that the UBC factor V, that is the base shear as per UBC-97 in north-south direction, the coefficient is 0.0554. Whereas in my calculation, manual calculation, it was 0.0555. So it does not make any difference. But here, the weight of the structure comes out to be slightly more than whatever I have calculated. In east-west direction, the coefficient exactly is the same, 0.044, and the weight again is slightly higher than whatever is calculated manually. Means what? That means we can safely use the load generator of STAD in UBC according to UBC-97. But be careful one thing. You have to calculate the period first and you have to assign time period in your definition of the seismic load. Then you will get the proper coefficient for the base shear and you will get the correct result. Now, load combination is very important factor over here. As I mentioned that UBC 97 gives load combination like this: 1.4D plus 1.7L, then 1.1 into 1.2D plus F1 into L plus 1.0E, that should be equal to 1.32D plus 1.1 F1L and 1.1E, and 1.1 into 0.9D plus 1E, which is 0.99D plus 1.1E. F1 is equals to 1 for the floors in places of public assembly, for live loads in excess of 100 square feet per 100 pound per square feet, and for the garage live load. Otherwise, for other loads is 0.05. The earthquake force E is determined from UBC equation, which is 30.1. This equation 30-1 is equals to E is equals to rho times EH plus EB. This load combination is very important. This definition of earthquake load is very important. Rho is a factor. You can safely take rho as 1, not an issue. Otherwise, there is a formula for rho and there is a way to calculate the exact value of rho. But most of the time, the value of rho is safely 1, because it cannot be less than 1 and it should not be greater than 1.5. So most of the time the value comes out to be 1. So I took the value of rho as 1. So the effect of earthquake E should equal to effect of horizontal earthquake, or the horizontal component of the earthquake plus the vertical component. This vertical component is very important, because in vertical component, as you can see, the vertical component should be 0.5 Ca into I into D, which comes out to be 0.2 D. That means 20% of the dead load should be used as a vertical load in case of an earthquake. Now, this 20% of earth load, it may increase the weight of the structure. If the motion is downward, it may decrease it can increase the dead weight by 20% if the structure is moving downward, or it can reduce the weight of the structure by 20%. Sorry. It can reduce the weight of the structure by 20% if the component, or if the structure is moving upward. So you have to consider plus and minus both. So once you consider plus and minus both, only then you can find the correct result. Now, having given the value of rho is equals to 1, So the E will be equals to 1 into EH. That means 100% of the EH horizontal component plus 20% of the weight of the structure in vertical direction. So the now your load combination finally it will be equal to 1.54D plus 0.55L plus 1.1 EH, and the last combination will be 0.99D plus 1.1 E, that will be ultimately equal to 0.77D plus 1.1 EH. So these two load combinations should be used carefully whenever you are designing the structure, concrete structure, especially as per UBC 97 or Pakistan Building Code. Now, let me show you the input data file. Now, here, before designing, I activated the load cases from 8 to 16 only. All the other load combinations I ignored. So here, the load combination from here, as per the calculation, I have defined the load combinations manually. Although I generated automatically, but then automatically generated load combination is different than this one. That is what I wanted to show to you guys, that please, if you are following UBC 97, do not generate blindly the load combination, because here you can see the load combination are not exactly the same whatever we have calculated over here. So that's why I manually input the load combinations as per my final calculation. Although I I generated the load combinations, but these factors are totally different. So instead of taking generated load combination, be careful and use the load combination as per your calculation. So this was the very important factor which I wanted to discuss with you guys. Now, having all these definitions, defining the load cases, defining the load combinations, and then you can run the model, and then you should design this building as per as per ACI 318, not 99. Be careful. I'm telling you again. Whatever I have done, I designed this building as per ACI 31811, so that the load combinations which I have defined by default, the earthquake load is ultimate load and all my load combinations are correct. One more factor that is in the modeling. If you see my load case number 3, at the end I ask model calculation requested. Why I inserted this command, why I was interested in model calculation? Because I was interested in mode shapes. The mode shapes which were given in PCA notes, and it is mentioned that the floors are considered as rigid frames or rigid planes or rigid diaphragms. So to simulate that, whatever is needed, that you have to define the master slave nodes. So for each and every floor or each and every slab, you have to define a master and slave nodes. What will be effect? What will be the effect? The effect will be that all your modes will be very exactly same or similar to the modes calculated by other guys, or rather this should be the realistic way where the slabs they behave as a rigid frame. If you do not do that, you will get misleading frequency information. So that is also very important. So that means, well, let me show you a few modes. Okay. Now this is mode number one. You can see the mode number one, exactly the building vibrates as expected. This is the fundamental mode. If I did not have defined the master and slave joints, then the result will be totally different. So be careful, guys. If you are going to calculate the mode shapes, or if you are going to calculate if you are going to define the seismic load, then this model is very important, or this point is very important, that you should define the slab as a rigid diaphragm. With this definition, you will get the proper mode shapes and proper frequency. Let me show you the second mode. See this second mode? Let me show you the third mode. This is the third mode. Fourth mode. Now this fourth mode is, I can say, this is not the fundamental, rather this is the next frequency or next mode shape in east-west direction. Sorry, in north-south direction. You will get proper mode shapes. I'll show you the another one. So this is in vertical direction. Anyway, the point is, let me conclude my video now. If you are going to design a structure against the seismic load, and especially if you are designing in Pakistan, then please be careful, define the loads as per UBC 97, but be careful whenever you are designing the concrete structure. Do not follow ACI 31899. Follow the later ones like ACI 31811, which is safe. Second thing is load combination. You have to be very careful in load combination. You have to follow a UBC 97 load combination. Only then your result will be okay. Then the third thing is, in defining the structure, do not forget to define the master and slave nodes for the rigid diaphragms. So if you consider all this information or all these recommendations in your design, hopefully you will get a much better result, and you will be very confident. Let me conclude my lecture over here. Maybe in next lecture I will show you that how STAT has defined the beams and columns and slabs, or how I have defined, and how the beams are designed in PCA notes. So that should be covered in a different lecture. So for the time being, I'm going to conclude my lecture now. One request, please do not forget to subscribe my channel, and you can share my videos whenever and from where to whom you want. No issues. I will be very happy if you share my videos. Thank you very much. Bye.